Hello and welcome back, everyone. Today we are finally here to showcase a little tool I've built with the help of Gemini, also known as Google's AI, which is the Panini.tox. And the way it works is it takes an input of a cube map and it essentially projects it as a Panini projection. You don't really need to know much about it because we are going to dive a little deeper into what it means, what it is used for, and whatnot. But all you need to know is that it is a particularly useful tool whenever you're trying to represent a three-dimensional scene, in this case, a simple instancing system based off of a point cloud. And you decide that you want a particularly high field of view. There's a bunch of parameters that you can see here, which allows you to really customize the overall look and compensate for much higher FOVs that you normally would. But before we dive into this patch, I say let's analyze a bunch of different cases, which are all going to be inside of these containers, which, by the way, are going to be part of the overall network, which you'll find on Patreon. And the component itself, though, don't worry, is going to be for free, available for free for everyone still on my Patreon, unlike the rest of the patch, which contains a bunch of custom rendering techniques, which we're gonna only view at a surface level during the duration of this video. So without much further ado, let's get down into the other cases. So in our first scenario, we have what you usually see in pretty much every basic rendering of a three-dimensional environment in TouchDesigner and many other media applications, where you have an object. In this case, it's just an instanced point cloud. And we have an FOV slider. We can move around with the camera thanks to our paneling functions given by the camera viewport component, which we can find over here. And we can also display two geometries in particular, the 3x3 cage, which it's essentially just a box of dimensions, I believe 10 by 10 by 10, correct? And the projection itself, which is essentially the section of a circle, which uses the FOV to calculate how much of the circle should be actually displayed, and it moves in accordance with the camera, as you can see from the little geometry preview over there. So normally in this kind of scene, if we start to increase the FOV, we'll start to see that the overall geometry occupies less and less space the higher the FOV is. And we also notice the distortion on both the local cage and the projection geometry. So for the cage, as we can see, despite the fact that all of these boxes are technically the exact same dimension, they get really heavily distorted. And the exact same thing goes to the section of a circle that we're using, as you can tell by this preview. And yeah, that's pretty much what happens in every standard rendering system, not just TouchDesigner. This also happens in Blender, Unreal Engine, Cinema, Houdini, and whatnot. So this is just your average day-to-day case kind of deal. So let's go and examine some other cases. The next case we're going to analyze is the one of a fisheye projection. I don't really have much to say about this. If you've ever worked with dome projections, this is the de facto standard of what's get used, I believe, something like 90% of the time. Maybe some people would just do something like a CubeMap projection, but then they still have to convert it into something that is more of a fisheye projection. And we can also, again, toggle the 3x3 cage, which showcases the heavy distortion happening to our box, almost going into sphere mode if it wasn't for the fact that it only has a few lines to really represent itself. And the projection here showcases the sphere where, or rather the half sphere, because it's 180 degrees, where everything is being mapped onto. And a curious thing about this is that because it's a sphere that is just attached in front of the camera and it's moving in accordance with it, whenever we get close enough to our point cloud over here, you actually start to see the little boxes pass through the sphere itself, which I think can give some very interesting results actually. But yeah, again, not much to say. Of course, being a fisheye projection, you can only see things up to this circular mask, which gets to like all the way at the top, right, bottom, left, but everything outside of this radius is just there's nothing. The output itself produces absolutely nothing, and this is why I just decided to put this little checkerboard kind of thingy in order to make more sense of it. But yeah, let's go ahead and get to the following example. So the next example in the list is a CubeMap, which for those of you who were paying attention is what I just mentioned before during the fisheye, which because sometimes you'll see people rendering things as a CubeMap and then maybe reprojected later on into a fisheye perspective. For those of you that don't know what a CubeMap projection is, essentially you take the position of the camera, and I believe you have a cube where each surface here is essentially a 45-degree field of view per each side, allowing you to represent the entirety of the surrounding area around the camera itself. And what in essence this means is that what you're seeing here at the very center is the front of the camera. What you see here is on the left, right, top, bottom, and then the one all the way in the back is what is essentially behind you. We can see what the cage looks like, and yeah, I think it gives sort of a tesseract look to the box, which is actually really, really cool. And the projection, well, it's a box and there's not much to say. Although one very cool and interesting thing about this is that if I get close enough, yet again, similarly with the fisheye and the sphere, you start to see the boxes actually popping off of the little lines of the projection representation inside our preview. A curious thing to say about this is actually that normally if you try to send a CubeMap onto the panel of the container here, TouchDesigner just does not allow for that. I imagine there is some technical reason for it, or maybe they never foresaw someone even trying to do such a thing, so they just never really implemented it. But I still needed to try and find a way to fix that. So for those of you that don't want to spoil it to yourself, you can just go to the next section if you want to try and give it a guess for yourself by just trying developing your own solution for yourself in TouchDesigner. But for those of you who are still interested, the solution to this little issue is, that's the box projection, is to actually still render a CubeMap and then just grab the output inside of the viewer as an OP view top, and yeah, that's pretty much it. So this is at the end still a 2D flat output. It's just that it's being grabbed off of a CubeMap node, and yeah, that's pretty much it. And yet again here the projection is just oriented with the camera viewport again. So let's keep it going. Next example. So next one in the list is the Equirectangular Projection, which you may know from either environmental maps or just in general stuff like HDRIs. Usually, or rather, I think they exclusively use this this format. And the way to render it in TouchDesigner, for those of you who don't know it, is to just get a CubeMap yet again, and then use a projection top to transform it into an equirectangular. Here I had to rotate it by 90 degrees because otherwise, yeah, the default rotation puts the front side, I believe, slightly to the right. I didn't want that. Yet again, we can see the 3x3 cage, which gets insanely distorted. It's a really, really heavy distortion that is happening over here. And the same goes for the projection. I saw that there's like a bunch full of different ways to get to showcase just how extreme the distortion is. With the sphere, you're seeing this kind of grid result, which is not exactly something you would really think of. With the box, you get a simplified version of the whole thing, but with the tube or cylinder, I think it really shines because it just showcases perfectly where each and every element of this 3D environment is going to go into our 2D projection, specifically this 2D equirectangular projection. So if I go through it, you can see perfectly where each and every single instance is going to go. So yeah, that was the equirectangular for you. And I believe that's all with the projection types. And we're now going to switch into a slightly different kind of lesson. So last but not least, we have the depth and the depth mask and the lookup tables. This is one of my favorite techniques I've really abused of in the past, I think, month and a half. There's some really interesting things that you can achieve with it. So by default right now, we're not seeing anything. This is just our standard render. It's just, 2D flat screen onto which we are projecting our 3D environment. And this is just your default result. We can turn on the depth mask, which showcase things as a gradient going from black to white, where black means close to the camera and white means far away from the camera. But thanks to the beauty that is lookup tables and a bunch of extra techniques that you can get, you can actually alter the distance that is being represented, or rather the distance at which the system thinks that things that are being represented is, which is a lot easier if I just showcase you. So remind you, black means close, white means far away. But now we can alter that with a lookup table. So right now what we get is a completely different result where things are black if they're the closest, then if they're slightly further away, they go white, then black again, then white again, and so on and so forth. And this can then be transformed much further by just doing essentially whatever you want. In this case, I just decided to use a transform and shift it through space. So as you can see now, we are shifting the theoretical distance at which everything is. Of course, we're not actually changing the distance. We're just eluding the system that the distance is being changed live, even though it isn't. And this can be used to create some really interesting results. One of them, for example, in this case is it's using this custom depth mask plus the lookup table instead of a matte, for example. So in this case, we are shifting between the default colors and simply a noisy version of the same. We can then do similarly the same thing with a luma blur, where we elude the system that things are like far away and then close up again and then far away and continue to do so on and on and on. And we can potentially even mix them all together to get some really funky results. So now that we've seen all of these elements together with one another, let's go back to our Panini projection, which is a much cleaner network as well, rather than whatever you're seeing over here on my left side. So last but not least, again, we are back to our Panini projection, and I can finally showcase the inside of the network. And as you can see, it's surprisingly compact network. If you even ignore these few nodes, which is I just use as a quick rendering, just to give an example on the TouchDesigner Discord server, I think it was, you can see that there's not much more than what I mentioned before. It is just a cube map, one for the normal render and one for the depth mask. They are both being passed through the Panini.tox, which has its parameter bound to one another because it makes it a lot easier to alter it. We are using again the same technique about the lookup texture against the depth mask, and then using it inside of a Luma blur to shift and the focus through the depth, which gives this sort of tilt shift kind of look to the overall rendering. And we can now play a little bit with the parameters here, although I highly encourage you to do so yourself after you've downloaded the Tox. But let's try something out. For example, we could lower down the D parameter a bit and re-increase the field of view up to 150. We could go even higher, like 165, and reduce the D factor yet again. And I think it works pretty well, especially considering I just used Gemini to do all the heavy lifting there. We can also exaggerate the output resolution. So for this case, I believe I have 237. Yeah, this should be a 21:9 aspect ratio, but we could exaggerate this even more with, it would be 3840 by 1080, which is, I believe, a 32:9 aspect ratio. And this would normally not look like this in a standard 2D projection. As a matter of fact, let me show you what it looks like if this was just rendering normally, which you can do by turning off the auto fit parameter and lowering the D parameter all the way to 0. So yes, this is what you would see at the current field of view. So that's why I developed this tool in essence. But yeah, there's not much more to say, honestly. You'll find the link in the description for everything mentioned in this video, a bunch of extra resources and whatnot. And in case you missed it, in the last video, we actually have a special discount code to join Billiam's Patreon at a lower price all the way through June. I believe it should end the 1st of July or something like that. But I highly encourage you to just go and check out the previous video for more information about that. And yeah, reminder, if you're seeing this video, it means that the Panini.tox itself is already out. The network, I'll publish it once it's fully adjusted. And yeah, thanks again for watching. Let me know if you have any issues with the tool. I'll try my best to see if I can fix it, and most importantly, send me results. I'm really curious to see what people are gonna use this tool for. So yeah, thanks again for watching, and I hope to see you on the next one. Bye bye.